All right, forget staring at endless spreadsheets for a second. What if you could just talk to your data? Ask it a direct question and get a perfect, precise answer right back, like instantly. Sounds kind of like sci-fi, right? Well, it's not. It's a language. And today, we're going to learn the basics of how to speak it. So just think about a university for a minute. It is just this massive, chaotic web of information, isn't it? You've got thousands of students, hundreds of courses, dozens of departments, all with their own schedules and budgets. I mean, how do you even begin to keep track of all of that without it just turning into a total mess? Well, the secret isn't just about storing all that data in some giant digital filing cabinet. No, the real power comes from being able to interrogate it, to ask these sharp, specific questions that pull out the exact piece of information you need right when you need it. And the tool we use for asking those questions is SQL, which stands for Structured Query Language. You can think of it as the universal language for talking to databases. So, for the next few minutes, we're going to go on a little quest for answers, and SQL is going to be our guide. Okay, let's dive right in with our first scenario. We're going to help the university dean with a pretty simple request. And while we're at it, we'll learn the most fundamental commands in the entire SQL language. So here's our mission. The dean needs a simple list. He wants to know all the buildings on campus that have smaller classrooms, specifically any with a capacity of less than 100 people. It's a super clear, direct question. Now let's see how we translate that into SQL. Okay, so the core of SQL is actually incredibly intuitive because it reads almost like a sentence. You just tell the database, select what you want to see from this specific table where these conditions are true. That's it. That's the basic grammar for almost every question you'll ever ask. Now, here's a really crucial detail. Let's say the Watson building has 2 small classrooms. If we just ask for the building name, Watson's going to show up twice on our list. And that's the default. It just gives you everything. But the dean doesn't need all those duplicates. He just wants a clean, simple list of the buildings. That's where Select Distinct comes in. It's like a magic wand that just tidies up our results and gets rid of all the repeats. So let's put it all together. We select distinct building from the classroom table where the capacity is less than 100. And boom, just like that, the database gives us our perfect, clean list. Painter, Taylor, and Watson. First question, answered. That wasn't so bad, was it? Okay, that was pretty straightforward. But what happens when the answer isn't all neatly tucked away in one place? What if part of your question is in one data table and the other part is in a totally different one? Well, this is where SQL gets really, really powerful. All right, we've got a new challenge from the dean. Now he wants a list of students, but the condition? It's based on their department's budget. The problem is student names are in one table, and all the department budgets are in a completely separate table. We've got to link them together. So how does SQL connect these two tables? It uses a process called a join. Now, the whole reason data is kept in separate tables is to be efficient and avoid just repeating everything. A join is the magic that reconnects it all. You can kind of think of it like a huge matchmaking game. First, the database imagines every single possible pairing of a student with a department. Then it goes through that massive list and filters it down, keeping only the pairs that are a perfect match, where the student's department name is exactly the same as the department's name. And here's that query in action. See how we're selecting from both the student and department tables? We even give them little nicknames, S and D, just to keep our code clean and easy to read. Then the where clause does 2 things. First, s.depName equals d.depName does the actual join, linking the tables. And then the and adds our filter, so we only see the results with a budget under $100,000. Awesome. So we can get specific data, and we can connect data from different places. But right now, our results are just coming out in any old random order. Let's fix that. It's time to learn how to organize our output and make it look professional. The command for this is beautifully simple, order by. You just tell it which column you want to sort by. You can use ASC for ascending order, think A to Z or smallest to largest number, or you can use DESC for descending order, so Z to A or largest to smallest. Easy, right? And what's really cool is you can even do multi-level sorting. Check out this query. We order by dept name ASC, so all the departments get grouped together alphabetically. But then we add tot cred DSC, and that sorts the students within each of those departments by their total credits, from the highest to the lowest. This is how you turn a messy data dump into a really useful, readable report. So let's zoom out for a second and think a little more abstractly. The result of any query you write is really just a list of data, what we call a set. And SQL has these amazing tools that let us treat these lists like they're building blocks, so we can combine them, compare them, and even find the differences between them. All right, here's our next problem. We need a list of courses, but they could be from the fall semester list or the spring semester list. How in the world do we combine those two separate groups into a single answer?
One of the great things about SQL is that there's often more than one way to get to the right answer. For this, we could use the in operator. It's perfect for checking if something matches anything in a short list. Or we could be a bit more surgical, write one query just for fall courses, a second one for spring courses, and then use the union operator to basically stack the two result lists on top of each other.
And union is just one of these set operators. Think back to those Venn diagrams from school. Union gives you everything in both circles. Intersect gives you only that little sliver in the middle where they overlap, the items that show up in both of your lists. And except is pretty cool. It gives you what's in the first list, but not in the second. These are some seriously powerful tools for comparing sets of results.
We have arrived at the final and honestly the most powerful section. So far, we've just been pulling lists of raw data. But now we're going to learn how to do calculations and summarize that data to find some real, actual insights.
These 5 commands right here, they're known as aggregate functions, and they are your big picture tools. They totally shift your focus from looking at individual rows to looking at entire columns of data, and they boil them down to a single summary value, like an average, a total count, or a maximum value. And this is where it all comes together beautifully. We can ask a question like, so how many courses are being taught in each building? By using count, SQL doesn't give us some long, boring list of courses. Instead, it gives us this powerful summary. We can see at a single glance that the Taylor building is the busiest, hosting 5 different courses. This is what it's all about, turning raw data into knowledge you can actually use. So let's just quickly recap our journey here. We helped the dean answer every single one of his questions. We started by selecting and filtering basic data, then we learned how to connect tables to see the whole story. We organized the results to make them readable. We combined different lists of data, and finally, we summarized everything to find those high-level insights. We've built a complete SQL toolkit from the ground up.
You now know the fundamental grammar of data's native language. The barrier that was between you and the answers hidden inside all that data, well, it's starting to crumble. So the only thing left to think about is, what questions will you ask?